Hello and welcome back. Okay, so right now we are discussing how addition is done when we're dealing with algebraic inequalities. Okay, so this is going to be the first rule that we actually try to find out how you actually play with algebraic inequalities. So first of all, for that we need our sample inequality out. Okay, so let's say we are given the following inequality: x plus 2 is less than y. So let's actually see how we can modify this inequality without actually affecting the intrinsic nature of this, which is basically to say how to not destroy the inequality and do some normal addition stuff. So so this is the actual definition, which basically just says that you can add any number, okay, but you have to do it on both sides. Again, this is I think this is exactly the same as how we discussed previously in our equations video, and it isn't different when we're dealing with inequalities in this case. Okay, so again, we're dealing with addition, and the symbol that we're going to be using is the plus sign, and you can have any number added to both sides. Okay, let's say you want to add 3 or -2, you can do that. But the only thing is that you have to do it on both sides. Okay, do it on both sides, and you can add any number, no problem. Because let's say you add the number +2, you can do that as I have done, or as you can see on the screen. I've done it on both sides, and it does not affect the inequality. The inequality holds, and everything remains beautiful. Okay, so we can. So this is actually just the basics. Okay. Just the basics, really easy to do. Take any number you want and just put it on both sides. Okay, so let's actually go through an actual example. That is always useful because we actually get to see the rule in action. Okay, so let's say you want to find out the value of x. So in this case, to find the value of x, okay, you need to get rid of the -2, which is right besides the x. Okay, again, whenever we're trying to find a value of any variable, for example x in this case, we need to have the variable isolated on one side. Okay, in this case it's going to be the left side, and we want all of the other stuff to be on the right hand side, and then it's always better to have that whatever is on the right hand side to be simplified. So let's actually first of all add 2 on both sides. Okay, we can do that because 2 is just, again, it is just a number, and we're doing it on both sides, so the rule holds. So we do that on both sides. Okay, and on the left hand side you can cancel out the 2's. Mr. Captain is always there to help us out with that, and what we're left with is just x. And on the right hand side we can just normal add the stuff. Okay, so 3 added to 2, that is just equal to 5. So right now we have just found the value. In fact, we have found the values of x, because in algebraic inequalities, we can't actually find the exact value. In this case, but we can actually narrow down the possible values. So in this case, we have narrowed down quite a bit. We have said that whatever the value of x is, it's just going to be less than 5. So again, not exactly pinpointing what the exact value is going to be, but again, a lot of positive numbers have been eliminated as possible candidates for the value of x. So this is what we do when we're dealing with algebraic inequalities. So again, let's go through another example. So let's say we have the following an algebraic inequality: x subtracted with 3 is greater than 2. Now again, we want to find x. So how do we do that? We can do that by removing the -3. How do we remove the -3? We remove it by adding 3 on both sides, and that way, because we're doing the addition on both sides, we don't affect the inequality. And when we do that, on the left hand side we can have the 3's eliminated, because in fact they do. +3, -3 is equal to 0, and we're left with x. On the right hand side, 2 added to 3 again is equal to 5. Okay, so again that is equal to 5, and we get the same actual result. I mean, we got the same result previously, but again, in this case, we have eliminated a lot of possible candidates, and the only thing that is left is that we know that whatever the value of x is going to be, it's going to be greater than 5. So it's not going to be less than 5. It's not going to be -7, -10, or anything. It can be 6, 7, 800, 8,000 something. It's going to be something, but it's always going to be greater than 5. So that is basically how you do addition in algebraic inequality. So I really hope you learned something, and thank you for watching.